Let's look at a proof for the quotient rule for derivatives. The quotient rule states if we're looking at the derivative of f of x over g of x, we have f prime of x times g of x minus f of x times g prime of x all over g of x squared, assuming that g of x does not equal 0 here. Okay, so something to notice here is that we are looking at the low function times the derivative of the high function, low d high minus high d low, derivative of the low function, square the bottom, and away we go. So that's a rhyme for remembering this is low d high minus high d low, square the bottom, and away we go. Well, where did this come from in the first place? Let's look at the limit definition proof for this particular problem. So we're looking at the limit as h goes to 0 of f of x plus h over g of x plus h, our function at x plus h, minus our function at x, all over h. So our derivative should be this expression here. Now, I'm noticing that I've got these g's showing up in these denominators. So one thing that I can do to simplify the expression here is I can multiply the top and the bottom of this expression by g of x and g of x plus h. This will help get rid of some of these fractions because we have stacked fractions going on. And when we do this step, limit as h goes to 0, I'm going to write out the longhand for the top, f of x plus h. It's picking up a g of x and g of x plus h for this first fraction on the top, still over g of x plus h. And the second rational is picking up a g of x and a g of x plus h all over g of x. And this entire thing is over h. Now that h is getting multiplied by g of x and g of x plus h. So multiplying the top and bottom here of this big fraction by g of x times g of x plus h really seems to have made things worse here. But let's simplify a bit. I'm noticing the g of x's cancel. G of x plus h cancels for the first one, and the g of x cancels for the second one. So the pieces that are left, f of x plus h, g of x, and I also have, and I'm leaving a lot of space here on purpose, f of x and g of x plus h are the only things that remain on the top. And in the denominator, we still have the h, as well as that g of x plus h. F of x plus h kind of has a derivative flair to it. If I had f of x plus h minus, and I'm going to do this in a different color, I'm going to do this in red, minus f of x times g of x, then this f of x plus h minus this f of x, that feels like the derivative for f. Now I can't just subtract something randomly. I have to keep everything balanced. So if I were to randomly subtract in the center like this, I would have to add to counteract it. This seems to make things worse before it gets better, but let's look at grouping this together here as two separate expressions. Let's look at the limit as h goes to 0 of f of x plus h times g of x minus f of x g of x. So grouping together these first two things, here we are. And let's also look at the limit as h goes to 0 of f of x g of x minus f of x g of x plus h. And this is all over for each of these things, h and g of x gx plus h. A lot of pieces, but it's gonna start to get real clean real fast here. I like that this has this g of x plus h, but I really wish that it would lead with that in the same way that this other one led with f of x plus h. So in this next step, what I'm going to do is just switch some things around, but be really careful with my signs. F of x plus h. Okay, and let's factor as we go too. These both have g of x. So I have f of x plus h minus f of x times g of x here for that first piece. And let's see what this looks like for the other one. And this is all over h g of x plus h. And for this next limit, h goes to 0. I'm noticing these share in f of x, but I want to start out with g of x plus h. And then I want that g of x to come next, where both of these things are getting hit by f of x. Now, the problem with this is I can't just switch these two things around, the g of x plus h and the g of x, because doing that would change the sign. So I'm going to put a negative in the front. I'm switching this outside positive to a negative so I can switch the orders of my g's. Let's highlight some of these pieces together and let's see what's left. So for this first one here, I've got f of x plus h minus f of x all over h. That's the derivative of f. I've got g of x plus h minus g of x all over h. That yellow piece is the derivative of g. So let's write those in with the functions that we have on the top. F prime of x times g of x. And over on this other side, that's the derivative of g prime of x times f of x. And let's see what's going on the bottom. I have g of x times, and if this is just going to 0, then that's x plus 0. That's just x. So I have g of x times g of x. I have g of x squared. Same here, g of x times g of x. That's g of x squared. Writing this as a single fraction, I have the derivative of f times the g of x minus the derivative of g times f all over g of x squared. Bit of a walk, some complicated fraction stuff going on, but that's what it looks like there for finding the derivative using the limit definition. Let's check out more of these together.